To solve the following root equations, we're going to square both sides to cancel a square root. So for question number 1, we have the square root of x plus 4 is equal to 1, and I'm simply going to square both sides. On the left, squaring a square root gives me x plus 4, and on the right, if we square 1, we get 1. Now to solve for x, we can simply subtract 4 from both sides, and we get that x is equal to negative 3. And this is the solution to the equation. It's important to check. You can put negative 3 in place of x and just make sure the left and right side are equal, but this is a solution to the equation. For problem 2, I'm going to just note that there is no solution. There's no way the square root can yield a negative number, but I want to go through this process just to see what happens. So I'm going to take the square root of 2x plus 1 is equal to negative 3, and I'm going to square both sides. On the left, we get 2x plus 1, and on the right, if you square the negative, it's positive, and 3 squared is 9. Now to solve for x, we can subtract 1 from both sides, and then divide both sides by 2. And we get that x equals 4. It looks like it is a solution. But if we check this in the original equation, you would put 4 in place of x and ask yourself if this is true. Well, on the left, 2 times 4 is 8 plus 1 is 9, and is that equal to negative 3 after we take the square root? And of course the answer is no. So this is a possibility where it looks like through this process you end up with a solution, but it turns out when you plug it back in, it does not work. So for this reason, there's no solution to this equation. For question 3, same idea. I'm going to take the square root of x plus 3 and x minus 3 and square both sides. Because at the very least, the left is simple, it's x plus 3. However, I have to be careful on the right. X minus 3 squared means x minus 3 times x minus 3. So I have to distribute to multiply this together. X times x is equal to x squared. X times negative 3 is equal to negative 3x. Now I multiply in the negative 3. I get another negative 3x. And then negative 3 times negative 3 is positive 9. So just be careful when squaring out something that looks like two terms. It's not just the first and last term squared. You get these two middle terms. Altogether, we have x plus 3 is equal to x squared minus 6x plus 9. My approach is going to be to subtract x and 3 from both sides of my equation, setting it equal to 0. We have x squared minus 7x plus 6. To find the solutions, I'm going to factor this expression. Okay, it's got to be x and x, has to be negative and negative. 1 and 6 multiply to 6, yet add to negative 7. This means there's two potential solutions, 1 and 6. But it turns out that 1 does not work in the original equation and 6 does. Therefore, 6 is the solution to question 3. So let's try the same idea on the next one. Again, I'm going to square both sides. And on the left, we again get x plus 3, no problem there. But I'm going to be careful here. I get x squared, I get positive 81, but there are two middle terms. That is, x squared, I get a minus 9x, a second minus 9x, and a positive 81. After I combine like terms, I get x squared minus 18x plus 81. I will subtract x and 3 from both sides, which changes my equation to 0 is equal to x squared minus 19x plus 78. Now, does this factor? Let's see. Again, it's got to be an x minus and an x minus. Okay, it is 6 and 13. The sum is negative 19, and the product is positive 78. This means our two potential solutions are 6 and 13, but as it turns out, 6 is no good and 13 works in the original equation. The last two will be very similar. What we're going to do again is square both sides. And on the left, we get x minus 4. On the right, it's x squared. We get 2 minus 6x's and a positive 36. If I combine like terms, I get x squared minus 12x plus 36. I will subtract x as well as add 4. Changing my equation to 0 is equal to x squared minus 13x plus 40. Okay, does this factor? I'm guessing it does. Both are again an x minus and an x minus. So two things that multiply to 40 yet add to 13 will be 8 and 5. That means 8 and 5 will be the two numbers that make the equation equal 0. It turns out that 8 is a solution and 5 does not work in the original equation. For the last problem, I think the trouble here will be the numbers are going to be larger. It'll be harder to guess the factors, but same approach. Square both sides. Okay, we get x plus 5 is equal to x squared. We get 2 minus 15x's, but a positive 15 times 15 is positive 225. If I combine like terms, I get x squared minus 30x plus 225. I will subtract x as well as 5. And this gives me 0 is equal to x squared minus 31x plus 220. Okay, an x minus and an x minus. The two numbers that multiply to 220 yet add to a negative 31 are negative 20 and negative 11. So therefore, 20 is a potential solution, and so is 11. But again, it turns out that the only solution is 20, 11 does not work, and that is it.